Here is a track that extends for 11 feet, between 3 and 4 metres. The most distinct tracks are made by the feet. There's one, there's another, there's another. But outside these footprints, there are other, rather more indistinct prints, which are made by the knuckles of the hand, without the little finger, which of course is enormously extended and supports the wing membrane and is cocked up in the air. There's one, there's another, there's another, and there's another. And when you examine the footprints, you can see that they have 4 toes, not 5, 4. That's a sign that these were made by short-tailed pterosaurs. And the distance between the feet varies. Sometimes it's relatively short, sometimes it's longer. And that's because these animals moved at different speeds. When they were moving at speed, they took bigger strides. So these show, this marvellous deposit shows that short tails on the ground were really very nimble indeed. And that's probably because the membrane between the legs in the short tails has been divided, so the legs have more freedom. So the short-tailed species were able to get about on the ground pretty well. And that was important because it enabled them to exploit new sources of food. Indeed, it might be the case that the future of the pterosaurs was assured, for some time at least, not by their ability to fly, but their ability to walk. This ability to walk had a profound effect on pterosaur evolution. There's evidence that from this time on, all kinds of new species began to emerge that fed on a wide range of different food. The short-tails proceeded to diversify into a great number of different forms, finding food in a great variety of places. And you can tell what they ate by their skulls. This one, for example, has what looked like a pair of tweezers on the front and very rounded teeth. It is thought to have been able to dig out cockles and mussels from the sand and crush them. So this was walking on the ground. This one, on the other hand, found its food while it was on the wing, and that it dipped down and seized big fish, which it stabbed with these teeth, and then carried off in its jaws to rip apart, perhaps on the ground. Others had dense rows of teeth that were so thin they were scarcely more than bristles. That enabled these animals to use their jaws like sieves to filter out small crustaceans such as shrimps and other small morsels. And some lost their heavy teeth altogether and evolved beaks. Adaptations like these were probably influenced not only by the different ways of eating, but by the universal need of all flying animals to keep their weight down to a minimum. So by about 80 million years ago, the short-tailed pterosaurs dominated the skies. Not only were they catching flying insects in mid-air, they were snatching food from the surface of the seas and filtering it from the shallows. This was the pterosaur's heyday. One species in particular symbolizes their success. It's called Pteranodon. It was the most common pterosaur of its time, and it was also very big. It measured about 18 feet from wingtip to wingtip. But how did such large animals manage to stay airborne? You can see the answer in this fossilized bone. It's hollow. It's been treated with acid so that you can see inside it. And inside, it's got a network of struts to support the bone. So it was very, very lightweight. The full extent of these cavities is revealed by X-rays. And a cross-section shows that they had another and very valuable function. This is the upper arm bone of a pterosaur. And at the top, it has a hole. And that's a clue as to how they generated power. Because it was connected by a tube to the lungs and internally to these cavities. So it was in there that the pterosaur was able to store air and the oxygen that it contained. And from that it could get the power when it really needed it. With all these ingenious adaptations for flight, the pterosaurs now had the freedom of the skies. But a new kind of flying reptile had been evolving away from the coast in the forests farther inland, and its arrival would have enormous consequences for the pterosaurs. In that remarkable quarry in Germany, another amazing discovery was made. Among all those shellfish, shrimps and fish, something utterly new had appeared. There can be no doubt about what it is. It's a feather. And a few months after its discovery, a quarryman found a fossil of the animal to which it must have belonged. Its outstretched wings made it quite clear to anyone that this was an animal that could fly. They called it Archaeopteryx. And this is what it may have looked like in life. The feathers on its wings are strong and rigid, so they don't need to be attached to the legs as membranes do, and it leaves the legs free so that they could run. The head doesn't have a lightweight beak like modern birds, but is still very much the head of a reptile with bony jaws and teeth in it. And the tail, too, has a line of bones running down its length, just like a lizard's tail. So this is half reptile, half bird. We now know that Archaeopteryx was not alone. There were several different kinds of feathered reptiles living about this time. Their skeletons are very rare, perhaps because they lived inland, where conditions for fossilization were not as good as they were in the coastal seas.